5.5, conditional probability. Let's take down some vocabulary words before we launch into these examples. So dependent events. Dependent events are events whose outcomes are affected by each other. So this takes it one step further from mutually exclusive. Mutually exclusive means that there is no overlap between events, but dependent events are actually related in that the probability changes based on the outcome of A or B. So here's what I mean here. So for example, if two cards are drawn, the outcome of the second, and let's just be a little bit clear, if two cards are drawn and not replaced, the first one's not replaced, the outcome of the second card depends on the first. So, i.e., the first card, if it's a standard deck of cards, the first is 1 out of 52, but the second is 1 out of 51, because there's one less card. Conditional probability is related to this. So conditional probability is the probability that an event occurring the probability, I'm going to change here, of an event occurring, given that another event has occurred. So the notation, what's the probability of A and B occurring? Is equal to the probability of A times probability of B given A. So this is the formula here, but let's unpack this little piece right here. The way that we would say that is the probability of B given A has occurred. And the understanding here is that that B is dependent on A. So let's launch into this example here. Calculating the probability of two events. Now, what is really helpful in dependent event examples is learning how to draw a tree diagram. So first things first, let's read the question, and then second things second, let's define our sets. Let's define our outcomes. So example number 1, calculating the probability of two events. A computer manufacturer knows that in a box of 100 chips, 3 will be defective, so 3%. Jocelyn will draw 2 chips at random from the box out of 100 chips. determine the probability that Jocelyn will draw 2 defective chips. Now the understanding here is that when Jocelyn draws that first chip, she holds it in her hand, and so then she draws the second chip. So essentially what we're saying is first time there is a 3% chance, but once you've taken out that one chip, the denominator is no longer 100, it becomes 99. So let A represent the event that one chip is defective. Let B represent the event that 2 chips are defective. And so the unwritten stuff here is it represents the event that 2 chips are defective when pulling out one at a time. So with our tree diagram here, we're saying that there are 2 possible outcomes for that first chip: defective and not defective. So this is for the first chip. Then we have our second chip, and both of these options here have a defective and a not defective. So you can pull out your first chip, it can be defective. You can pull out your second chip and it can be either defective or not defective. Or when you pull out the first chip and it's not defective, the second chip can also be defective or not defective. So I'm just going to highlight the branch that we want. So we want the defective first chip and the defective second chip. So the probability of A and B is the probability of A times the probability of B dependent on the fact that A happened. So what are the chances, what's the probability that both one chip is defective and not only one, but 2 chips are defective, taken out consecutively? This one is kind of like a fundamental counting theorem, because just to put it in this light, these are saying the exact same thing, but I know that my first chip is going to be 3 out of 100. However, that means that if you've picked out one of them, okay, when you've picked out one of these defective chips, there are now 2 defective chips remaining and 99 chips remaining in that bag. Okay. So when we do this, we're going to say that this is 6 out of 9900. And if we want to get it down in lowest terms, we can do that. This is a fully fine answer. Okay. But if we want to go down into lowest terms, it's 1 over 1650. So there is a 1 out of 1,650 chance that both of the chips will be defective that you pull.